first things first, you need to ascertain whether USB controller sync is actually your issue. So in order to do that, and to make sure the issue isn't actually with USB, you need to attempt to power the machine on. And we'll let that start up. Now, as you can see, down here we have our controller plugged in to the front of our PlayStation via USB, as normal. We've not touched that yet. Now it looks like somebody actually initialised this machine. So it's telling us to connect it to our controller to the PlayStation via USB, which is what we've done. So as you can see, the charging light's on. So if we attempt to sync that now, we're getting no sync at all. And that isn't detected at all by our PlayStation. So next thing, so we're happy it's not syncing. So we're going to power the machine down. And we'll give that a moment. So we've ascertained there that the console in OS mode has absolutely no controller sync whatsoever. So now we need to ascertain whether we actually have any sort of connectivity from our PlayStation to our controller at all. So we're going to go into safe mode. To do that, we're going to press and hold power. We're keeping it held. You'll hear a second beep. There we go. So we're going to release. And we're just going to let that come up now. So it tells us to connect our DualShock using USB cable, which of course we've already done. And now when we press the PlayStation button, and as you can see, we can cycle the menu quite happily. So that, to me, tells us that we have sync in safe mode, but we don't in OS mode. And that is a classic sign that indeed we do have an issue somewhere along the line with our controllers. So that is either firmware corruption or it's a duff Wi-Fi Bluetooth module. So the easiest thing to do first is to get the firmware from the chip and just make sure that that's okay, because it's a lot easier doing that than it is to replace a Wi-Fi Bluetooth module. A lot less work in it. So that's what we're going to go do now. So we are going to disassemble our PlayStation and see you in a sec. Right, so we've just popped the power supply out of the back of our PlayStation, and the firmware chip, you can see, is just here in this hole. So we're going to get a little bit of hot air around that, and we're going to pop that out using some tweezers and a bit of flux and a bit of hot air, and then we can get that into our programmer, and we can get that onto our PC, and then we can look to see if we have any issues there. Right, hello ladies and gentlemen, and welcome to part 3 of our series on repairing PS4 Controller Sync issues when that issue is caused by corruption in the PS4's NOR Flash firmware. And today, of course, as promised, we are going to look at the third and final part of this video series we have for you today. And we are actually going to go and we're going to dump the flash. We are going to repair that flash dump in a hex editor. Don't worry, we'll cover that in a sec. And then we're going to rewrite flash back to our chip, install our chip back in our PlayStation, and fingers crossed, everything's going to work out lovely. So hopefully you've seen parts 1 and 2 to this video series already. If not, we'll link them in an annotation just here. If you are on a 1200 series PlayStation, then you're also going to want to watch this little addendum video, which we'll link in just here. And then hopefully, once you've watched those parts there, you'll have the necessary equipment. You'll have managed to assemble that equipment into the programming hardware that we're going to be utilizing here today. Using part 2, you will have learned how to install that programming firmware onto your PC so that we can actually get a dump from that hardware programmer onto our PC, as we've got here. and then we can actually get onto it, manipulate it as need be, and then we can write it back and get everything done. So hopefully you've seen parts 1 and 2. If not, I do heavily encourage you to watch it. They are both required. In the case of a 1200 series, then you're going to have to go back and watch all 3. Like I say, those videos do cover hardware you're going to need to purchase, unless you have it already. A lot of you probably won't, so they are, I know you want to get going on this, but likewise, if you have sort of already been away and you've purchased your bits and pieces and you've built it and you've got it all installed, then you're a good way of the way there to actually getting this repaired. If you are just following along to see what's involved before you think, no, sod that, I'm going to take it somewhere else, then I absolutely appreciate where you're coming from, and settle down and come and learn with me. So my apologies today if I do sound a little bit croaky. I think my voice doesn't sound too bad actually, but I have picked up this bit of a tickle and a bit of a cough and cold thing going around at the moment. It didn't seem that long since the last time, but never mind. So hopefully I'll not be coughing down the microphone too much at you today. But as I say, thank you for joining me, and let's get on with things. So those of you who did drop by on the first couple of videos may have noticed that when we jumped onto this VM in part 2, that actually there's a new icon appeared on this desktop between now and the end of the last tutorial, and that is this zip file here. This PS4 C0020001 Templates.zip file. Don't worry, that is actually in a link in the description of this video. You need to download that. You are definitely going to need to go away and download that, because we're going to be using the files within there to actually fix our firmware. So go away, download that now. I think it's 2.64 megs. Yeah, 2.64 megs in size. For completion, I have already gone away and put this on our desktop. I would encourage you to save it somewhere that's handy. So your desktop too would be a good start before we do anything else. And before we start on actually doing anything with our firmware, we're also going to open a web browser here. And you're going to want to go to Google. And in Google, if you type HxD, and you'll notice that the first result here is HxD Firmware Hex Editor and Disk Editor. So the little download link there underneath, so we're going to click that. This piece of software is something called a Hex Editor, and what this does is this actually allows us to get into the guts of the firmware and manipulate it as need be. Now, obviously, we don't have this installed on this VM. This VM is something I set up specifically to go through this with you. I have this all set up working lovely on my actual laptop itself, but as I say, we need to show you what to do. So you're going to come to this downloads page here, and obviously you can pick your own language, but for us, we're going to be using English. And you can either download it from cnet.com, but they tend to bundle loads of crap with their downloads. But underneath there, you can see there's 2 extra options there: download per FTP and download per HTTP. So either one of those. I like FTP; it tends to be a bit quicker. So we're going to go for that. It's only a small installer. It's less than a meg in size. So once that's finished, you just want to open it, and then run the setup within. So obviously, if you get any security warnings, just allow them to run. And eventually you'll get the installer. Now the installer is nice and easy. It's literally, just accept the agreements and click through the default options. Absolutely fine. It only asks you where you want to install it and whether you want any shortcuts or anything there. We're going to place a shortcut to our desktop because it's useful, and then go away and hit install. Now we're not going to run either of these two just yet. We're going to hit finish on that now. And then you can get rid of that and get rid of your web browser, and you'll notice that you've now got a new little icon there for HxD, and we'll come to HxD shortly. The other thing you're going to want to go do right now is actually extract this zip file. So by now, if you're following along at home, hopefully that'll have just about finished downloading for you. So again, we're just going to extract this to our desktop, and yeah, this file is absolutely fine in that folder there. So as you can see there now, we have this folder just here, which contains all our bits and pieces. Again, we'll come to that in a sec. So hopefully now we are ready and raring to go. So what do you need to do? Well, hopefully by now you will have actually followed through and ensured that the issue that you have with your PlayStation is indeed the controller firmware sync problem, and it isn't in fact USB related. We covered that over a little bit earlier on in this video. So hopefully you're sure your issue is somewhere with controller sync. Now, I know what you're thinking, Andrew, is it worth me doing this, or is it worth me replacing the Wi-Fi and Bluetooth board? Well, unfortunately, there's no quick solution to that one. Unfortunately, there's no real way to tell. If I would say that if you have recently performed a software upgrade and when it's finished rebooting, it's come back up and you don't have any controller sync activity, then I would say, yep, chances are it's firmware corruption. If you change some system settings along the lines of rest mode or things like that, fairly low-level system options in the settings, and you've rebooted it and now it's come back up and you've got no controller sync, well, those bits are flipped in ROM, and it's quite possible that it may have corrupted your flash, in which case, yeah, this may very well be your issue. If it's been left on overnight, for example, and you start it up and it's come back to exactly where it left off and now you've got no controller sync, that may be hardware related, but that's only a very, very quick sort of overview, to be honest. To get the Bluetooth Wi-Fi boards off these boards, off these PS4 main boards, PS4 main board I think is at least 8 layers. That's a lot of copper. Takes a lot of heat. Takes some decent kit to actually get it off. So it's going to take a decent heat plate, decent air wand, air station, yeah, and a fair bit of skill to get them off. Certainly in one piece. So yeah, it's not easy. So it's definitely easier and kinder on the board to check this first. And to be honest, this is probably more likely going to be your issue than the actual hardware itself. But there we go. So that's a quick start of 10. This is definitely easier to check. So where are you right now? So hopefully, as I say, now we've confirmed the issue is indeed, either firmware related or at least related to the board in some way, and isn't actually a USB issue. Hopefully by now you will have gone away and you will have desoldered your PS4 NOR flash chip, whether it be the little WSON8 package as in the 1200 series, or whether it be the older 16-pin package that we see on the SAA and SAB boards, on the older CUH1000 series, 1100 series boards. Hopefully you've got that desoldered now. Hopefully that's been placed into your socket, and your Windows PC is booted up, and you have inserted your USB lead into your PC. You've just gone along and you've downloaded this zip file and extracted it with us, and also installed HxD. If you are there right now, then we are ready to go. So what's the first thing we need to do? Well, the first thing we need to do is go into either find my computer or this PC, and then right click on there and hit manage. And once you do that, you'll get this computer management window. Likewise, you can get to this through control panel, administrative tools, and computer management. So there's a couple of different ways of getting there, but either way, you'll see this same screen. And what you're going to need to do then is go down into device manager. So again, there's a couple of ways of getting to device manager. This is the way I tend to do it, but you can right mouse click start as well, I think. Device manager, there you go on Windows 10. I think it's the same on 8.1. I think it's the same as 8 as well if you hover into the corner to actually get the start button up. But anyway, I digress. So this is Device Manager, and this shows you everything that's installed and makes up parts of your PC. You'll notice, or hopefully you'll notice, that you have something here called ports COM and LPT. Expand that out and you will see hopefully something like this, USB serial device, and it will give you a COM number. So in this case it's COM port 3. So our teensor here is effectively acting as a little serial device. And that COM port 3, or COM port whatever it is that you've got, you need to make a note of that because we're going to be using that shortly. Okay, so now you've made a note of your COM port number and you can verify that you can see your programmer in Flash, we're going to prepare to start to actually dump our PlayStation firmware. So in order to do that, just go into this PC or my computer or wherever to get Windows Explorer up, and go into the root of the C drive. So just double click on C, and then create a new folder in there. I don't know, we're going to call ours PS4 BIOS. So all one word, no spaces. So this is where we're going to do all our manipulation of things. So now we've created that little folder there. Again, you might want to make a note of that name there. So C:\PS4 BIOS in our case. So make a note of that path there. And then you can, well, yeah, you can close that for now. So if you remember in the last video, we actually created a link to SPIway. So we are going to double click our shortcut to SPIway. We actually installed this little shortcut to our desktop and set it so that it pointed directly to the file where our SPIway installation even was sitting. So we obviously downloaded it and extracted it to this Norway master file. All the SPIway files are inside that folder. We created this little shortcut here to point to that folder. So what that actually does is that saves us having to go and type, cd.cd space c:\users\andrew/downloads /Norway master every time we want to issue a command. Because we're now in that, we have pointed this command interface already at this folder by using this really nutty little shortcut. It saves us having to type all that, and instead we can just type spiway.py and everything else. So it saves us a hell of a lot of typing and God knows what else. So if you didn't create that shortcut from the last part, I recommend you do it. It's a great time saver. So because we've already done that, if you haven't done that or you know what you're doing, then obviously just cd into that directory wherever it is that you installed your SPIway stuff to. And then basically what we're going to do is we're going to test the connection. So what we need to do is we need to type spiway, that's spiway.py, because of course it's a Python script, space. Now remember that COM port number we just got out of Device Manager for our USB serial device? Indeed, in our case it was COM3, so we are going to type COM3, COM3, and then space. And the command to ask SPIway for the basic information on the chip that we're going to be dumping and writing to is info, I-N-F-O. And if we hit enter, we can see there that it goes away, it pings the TNC, and it pulls back something called SPI information. So that pulls back the information on our flash chip. And as you can see, chip manufacturer is Macronix, which is OXC2. That's the identifier for Macronix. The chip type is MX25L25635F, in brackets 0x18, so that 0x18 is the identifier for that particular chip type. That's good, that's absolutely fine. Chip size is 32 megabytes. Sector size is 4096 bytes. The block size is 65,536 bytes. Sectors per block is 16. Number of blocks is 512. Number of sectors is 8,192. Now, we're not particularly interested in much of that information. The only bit we're really interested in, to be honest, is that it pulls back that the chip type is Macronix and that the chip manufacturer is Macronix and the chip type is the MX25L series of chip. And providing you see that and the chip size there is 32 megabytes, then you're good. We've confirmed now that indeed our chip is being identified properly and is actually nicely talking to our programmer, and our PC can talk to it and vice versa, and everything's happy. If you don't have a good connection between your chip and programmer, so say it isn't seated in the socket properly, or you've got a wire crossed and the wire's wrong, or you've got some wires crossed, or whatever, or your chip programmer isn't working properly for whatever reason, what you will see is something like this. So when you go to actually issue that command, what you'll see is something like this. So you'll end up with the same SPI information, but you'll end up with chip manufacturer unknown and chip type unknown. And then where you see closing serial device and done is actually where the TNC closes the connection and goes, yeah, told you everything I know, which isn't a lot. So if you do see something like that, check your wiring connections, check that the chip is indeed sat in the socket as desired. Make sure that all the pins are nicely touching the socket. If you have soldered directly to the pins on the chip, then make sure that the wires are correctly soldered, they're soldered to the right place, they're not touching any other pins, you know, that the connection's nice and solid, that your joints are nice and clean. And then, as I say, plug everything back in, just make sure everything's good, and then reissue the command, and hopefully then you'll see everything come back nicely. And providing you see this SPI information here, and as I say, your chip manufacturers and mechanics and your chip type is identified correctly, then we're good to go. So the next thing to do is to actually get a firmware dump onto our PC. So what we need to do now, we need to issue a command to SPIway to go actually get it to dump our flash. And to do that is really straightforward. So first of all, we call the script, which is SPIway.py, that's py. That's basically short for .python, so it's a Python script to remember. Next, we are going to tell SPIway which COM port it's going to use to talk to our programmer. Now remember, we've just checked and that is COM port 3. So it's SPIway.py space and then COM, whatever number your COM port is. So in our case it's COM 3. No spaces in that. And then space again. And we actually want to dump our firmware to our PC. So we type dump, D-U-M-P, and then space, and now we need to give it a path as to where we put it. Now it's important to remember that this path has to exist for SPIway to actually do it. It isn't smart enough to actually create a folder if it's missing. So remember, we just created that PS4 BIOS folder in the root of our C drive. So we are going to dump to C:\PS4 BIOS, and that is effectively our command there. So what we're going to do now, we need to give our dump a file name. So we've told it where that folder is, so now we need to give it a file name. So we're going to add another backslash, and we're going to call this file orig, so that's O-R-I-G, short for original. We're going to dump this several times to make sure we get a consistent dump, so we just need to put a number after it. So you can use 1, 2, 3, whatever. In my case, I'm going to go for 0, so orig 0. And then .bin. Now then, as I say, this is, you can call this anything you like. That file name at the end there doesn't matter as long as it means something to you. So as I say, you can call it 1.bin, 2.bin, whatever. In our case, orig0.bin. Partly because I'm old school and, you know, back in the early days of messing around with Xbox 360 drive firmware, the tutorials all used to tell you to use orig0, so it's just stuck. Anyway, so let's just go through that command before we issue it. So we are calling the SPIway.python script there. Then we had a space, and then we told SPIway the COM port that our TNC is assigned to in Device Manager. Then we have a space, and we tell SPIway what we want to do with itself. So that we've told it there we want to dump firmware. And then a space, and then we've told it where we want to put that dump. So we want to put that dump, remember, in that C:\PS4 BIOS folder. And we've told it that we want to keep, we want to give our dump a file name of orig0, and we want to put a .bin extension at the end of it. So once you've typed that or similar, go away and hit enter on your keyboard. And you will see now that SPIway will go away and dump our firmware. So this will take a couple of minutes. This will take around 2.5 minutes, something like that. I think it actually on average takes, for 32 meg flash across USB 2.0 on this particular laptop, takes between 2.5 and 2 minutes 50 seconds per dump. So we're going to do this a couple of times. So we're not going to skip this. We're just going to let it run through so you can see the speed of which it does this. Now, it's important to note that it is a lot quicker reading it than it is writing it. When we actually come to write this file back to Flash, when we've actually finished manipulating it, it's going to take around 11.5 to 12 minutes to actually complete that write process. So it's not particularly slow, but like I say, bearing in mind it's a serial over USB connection. It does take a little bit of time. It does it at around 60 kilobytes, per second, sort of write speed, if you like, on average, at least on this machine. So, you can go away and have a nice cup of tea once you've finished your handiwork. But for now, we're approaching the 20 meg mark. So it does tell you the size in kilobytes as it's dumping off here, hence why it says 32,768 kilobytes is the max file size, which is 32 meg in layman's terms. So we're just heading up to the 23 meg mark now. So you can see there we have some interesting information there about our chip device. So it tells us that the manufacturing mechanics chip type. So once you pull that information and it tells you that your information should effectively match that. If it does, then congratulations. I've got a pipe running above my head. That's annoying. Hopefully that's not picking up on microphone, otherwise that's going to really do your head in by the end of this video. Somebody must be using the sink upstairs. And there we go. So as you can see there, we've finished our dump. That was 1 minute and 4 seconds apparently. So that was a little bit quicker actually at that time. So anyway, it will return you there now to this this command prompt here. And once you've received this done message, if you actually go and check in that folder, see PS4 BIOS, you will find now you have this ovig0.bin file. And just make sure that the file size there is listed as 32,768 kilobytes. If you can't see that at the end there, because your file properties have been changed about a bit, then you can right click and go to properties, and then you can see there the size, not size on disk, the actual size itself there is given as 32 megabytes, 33,554,432 bytes in our instance. So as long as it's somewhere close to that, say OK. And again, you can close out of that. So as I said before, what we want to do is actually make several dumps of this firmware. So because we only really get one shot at this before we erase the chip and write over it with our new firmware, we need to make sure that what comes off is actually a valid, genuine dump of what's on there to begin with. We can't verify that with just the one dump. So we need, well, we're going to make 3 copies of it because, let's face it, 3 separate flashes to be corrupt in the exact same way, byte for byte, is so unlikely that Leeds United are probably more likely to win the Premier League in the next 3 years than that happening. And anybody who knows me knows I'm a Leeds fan, long suffering, and unfortunately we are just crap. But anyway, I digress. So in order to actually make a second copy of this, what we're going to do is we're going to leave the command prompt open, make sure the window's got focus, and just click on it. And then if you press the up arrow on your keyboard, you will notice that we actually go back to the previous command we issued, which was our dump command, and you can see there that we have the file name ovig0.bin. So if you hit backspace there and you just put, so we're going to increment the number by 1, so we're going to call this dump ovig1.bin. Press enter and it'll go away and dump the firmware again, and this time it's going to create another file in our PS4 BIOS folder, and this one's going to be called ovig1.bin. Now it's going to be the exact same file, or hopefully it's going to be the exact same file because that's the theory, and it's going to be created in the same place next to our ovig0.bin file. Once this particular dump's done, what we're going to do is we're going to go and we're going to do the same again. So press the up arrow on the keyboard and change the file name to ovig2.bin, or whatever you've called it. Just increment that number by 1. And then hit enter again. And what that's going to do is once that's finished, we're going to end up with 3, hopefully identical files in that directory. And then we can do some comparison and analysis of those 3 files to make sure that they're exactly the same. And then providing they are exactly the same, then we can go and actually do some manipulating and editing and repairing in HxD. It's all getting very exciting. So because that's going to take a couple of minutes, and we've just shown you how to dump this BIOS, and frankly you don't need to sit through another 4 minutes of watching this doing not a lot really. We're going to cut the video here and join me back once those 3 dumps is finished. So see you guys in a sec. Right, okay, ladies and gentlemen, and as you can see there, we have completed our 3rd dump, this orig2.bin, as we called it this time. This time it took 2 minutes and 52 seconds. So there we go. So anyway, what we're going to go and do now is we're going to go back into our PS4 BIOS folder and verify that again the orig2.bin file has been created and that its size is roughly what it should be. So 32,768 kilobytes looks pretty good to me. So now we've got those, we can close this command window for the time being because we're done with it for now. So the next time we go and utilize that, we'll actually be programming our excuse me, we'll actually be programming our BIOS back to our chip. So what we need to do now is we need to verify that these 3 files are consistent with each other, and we can do that in a rather nutty way in HxD. So that's the first thing we're going to go and do. So open your hex editor, HxD, and just maximize it to full screen. Now then, a lot of what's in this file is going to look incredibly scary in a moment, and I don't blame you because it is scary. Remember, it's firmware. It has to be absolutely perfect what we do to this firmware. If we do anything even remotely wrong, best case scenario, it's not going to work, and you're still going to have the same issue. Worst case scenario, the machine's not going to boot. So we need to be very, 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 very careful, and we also need to ensure that not only is our dump consistent, so in the worst case scenario we can at least go back to where we were. You know, that's the main thing. We need to ensure that we don't touch those original dumps at all. We need to leave them as is. So, but first thing, of course, we need to make sure that they're consistent, because if we actually have 3 different dumps, then how can we tell which one's the right one? So that if we do need to restore back to an earlier edition, we're pretty much screwed, because we can't lose what's on that chip currently, because that's unique to our PlayStation. So if we lose what's on that chip now, we have no way of getting it back. If we can confirm that we at least have a consistent dump across those 3 separate dumps, then we can be pretty sure that what is in those files is indeed what's on that chip, and then we can go ahead and do what we want with that chip. So that's cool. So that's what we're going to go and do now. So first things first, the little folder excuse me, folder icon on the toolbar there for open. Alternatively, you can go to file and open, whichever you would rather. So you just want to left click that, and it will default to your desktop most probably. So we're going to go, and you need to navigate down to that PS4 BIOS folder we created earlier. So we put it on C. PS4 BIOS, of course, you may have put your dumps somewhere else. Just navigate to wherever you saved them. And what we're going to do is we're going to Control A, or you can mouse drag all over them, or right click and select all. I do believe. Can you? No, you used to be able to do. Bloody Windows 10. Anyway, so make sure they're all open. All 3 files are selected, as you can see there, and then hit open. And that will open all 3 versions of our firmware in separate tabs. So you can see you've got like a bit like a web browser. You know, you've got different tab view there. So we've got Orig 0, Orig 1, and Orig 2. And that's cool. So we're going to leave the Orig 0 as the active tab. And of course, you know, feel free to have a flick through here. I mean, as I say, it looks incredibly scary. Don't worry if that top part's blank, that's perfectly normal. And as you can see, what I mean by scary is this. I mean, you know, how the hell can you tell what that's supposed to be? Yeah, you're not. The good news is you don't need to know. So anyway, what we're going to do is we need to make sure that these 3 files are consistent, i.e. that they're exactly the same. And HxD has a really nice feature which allows us to check that. So what we're going to go and do is we're going to go to this analysis tab. So click in there and then go down to file, compare and compare. Alternatively, you can use Control K on your keyboard as a shortcut. Either way, you will then get this little compare window open, and this basically allows us to compare 2 files byte for byte to ensure that they are indeed the same. So what we're going to do is source file, If we had HxD0.bin open as the active tab, that should already be filled in there. If it's not, then just go and select it from the list. Target file, and in our case is HxD1, that's great. So HxD0 in the top, HxD1 in the bottom. Hit OK. And hopefully, as you can see, it's layered the Windows top and bottom. So we can see both files. And hopefully you're going to get this little pop-up box here which says information. And it's got this really nice little message in there saying the chosen files are identical. Awesome. That's what we want. So we can be sure that HxD0 and HxD1 are exactly the same. So we have two identical firmware files. Brilliant. So what we're going to go and do now is we're going to go back to analysis, file compare, or again, Control K on your keyboard for a second time. Whichever you prefer. Source file still wants to be HxD0.bin, but this time we're going to change the target file. You just hit that little drop down arrow there, and this time we're going to select HxD2.bin. Say OK again. And this time you'll notice we have HxD0 and HxD2 layered on top of each other, and again we get this lovely message here saying that the chosen files are identical. Brilliant. So we can be sure that HxD0 is the same as HxD1 and HxD2. So our three firmware dumps are identical even down to the last individual digit. So that's brilliant. That means we have three firmware dumps all exactly the same. Hopefully you get that. If you don't get that and you end up with, where it says, it picks out differences and it shows you differences, or it tells you that the files are identical but the file size is mismatched, then go back, delete your dumps, check your connections again, and then redump them. 3 dumps from scratch until you get 3 which verify there as those do as all being identical. Once you've got those all identical, you can close all 3. So make sure none of those are opened in HxD. And then go back to that PS4 BIOS folder where they're all residing, or wherever you decided to save them to. And we're going to create a subfolder in there, and we're going to call it Originals. And then we're going to highlight all those files, and we're just going to drag them into that Originals folder. So all 3 of those files now are living in this Originals folder we've just created. We are not going to touch anything in these files. That is it. We don't, no matter how tempted we are, we ain't touching any of those. What we are going to do, however, is we're going to copy HxD0.bin, and we're just going to paste that back into the PS4 BIOS folder. Okay, so we've pasted it back into that PS4 BIOS folder. This is the file we are going to be doing some work on. The rest of these originals we're not interested in. So what we're going to do now is we are going to go, you can minimize HxD for now, and you can minimize that. And if you followed on from part 2, you should have this PS4 Acid Flash tool installed on your desktop. And what we're going to do is we're going to right click and run as administrator. Sometimes it works absolutely fine just running it normally, but sometimes you do get some rather weird .NET errors if you don't do that on some machines. So always an idea just to right click, run as administrator, and you should end up with this little menu here. So you want to click the extract button, and you'll end up with this PS4 NOR SLB2 extractor. And again, it looks like there's a lot of options and a lot of scary things in there, but don't worry about it, because we're only going to be using this to literally pull the various bits and pieces of our firmware apart. So essentially, we have a 32 megabyte copy of our PS4's flash in this HxD0.bin. Now, in reality, that one single .bin file is made up of lots and lots of tiny, smaller component parts. And it's basically just merged together into one big image file and then written up to the chip in the factory. And, obviously it's updated through system updates and things like that. But, that's effectively what that big file is. That big 32 meg file is essentially lots of smaller ones. What this Acid Flash tool does is allows us to get back at those smaller parts, those smaller chunks that make up our firmware, so we can actually get to the bits we want to manipulate and check them a little bit quicker and a little bit easier than it would be if we had to go through the whole lot. Because that's a big file if you ever have to look through it in its entirety. So first thing you're going to want to do is under this NOR dump section, it says select PS4 NOR dump to extract, and there's an open button to the right hand side. If you click the open button, and navigate to wherever you've just copied that dump file to. So see PS4 BIOS or HxD0.bin in our case, and open it. You'll notice that you actually get this console information box populated. Now, as you can see on the video, I've grayed some of this out because obviously it's pertinent to this particular machine. But obviously you'll be able to see your own. Now then, one thing you will notice is that it identifies your console's MAC address, the console's serial number, the hash of the firmware, this SHA1, including the console SKU model number. So in our case, this is a flash ROM from a CUH1116A. Now, firmware version here. You will notice, or you may notice, if your console's any older than anything over version 2, you'll notice that it says ff.f.ffffff. Now, you're thinking, hang on, yeah, but my console's version 3.55 or something. What's happened there? Acid Flash Tool is rather old, and it was developed, I don't even know if version 2 firmware was out. It might have been like something like 1.76, 1.78, something like that when this was new. So anything sort of certainly above 2.0, I don't think it recognises. So if you end up there with a firmware version, it doesn't, it just says Fs. But everything else seems okay, then you're probably good. Don't worry about it. The reason for that is because they actually changed the firmware identifier in the firmware. They moved it somewhere else. So this is actually looking in the place where it used to reside. So hence why it now doesn't know where to look and consequently just pulls back garbage data. So don't worry too much about that. We're not interested. The only thing we're interested in now is this second box from top where it says select the folder to save files in. And there's a save button to the right hand side. So hit that, and this time we're going to navigate down to see PS4 BIOS, or wherever you've kept your stuff. And this time we're going to create a new folder, so make new folder, and this time we're going to put original extracted. Something like that, because of course this is where the extracted bits of our original firmware are going to go. So say OK to that. So check your 2 file paths at the top there, where you're wanting to save things. So that's the bin file we're wanting to open up and have a look at, and that's where we want to put the various bits and pieces. So provided you've got that, nothing else matters. We're just going to hit extract now. It takes a couple of seconds and you'll get this NOR dump successful extracted message here. Say OK to that, and you can close Acid Flash now, and you can close out of that. That's all we're using Acid Flash to do today. So if you go back into your folder where you've got all your bits and pieces kicking around, you can see, in our case, it's PS4 BIOS. This original is extracted folder. If we go into there, we've got a folder now called flash_extracted. We go into there, and you can see all those individual bits and pieces, those lots of smaller bits and pieces that our PS4 BIOS is actually made up of. So the entire ROM is made up of these smaller bits and pieces. And you will have something in there. And those of you who remember or were eagle-eyed at the start of the video, we had this template folder that we downloaded, remember? And that was called C0020001. Recognize that? This C0020001.bin file here, that's because that particular bin file is the entire container for our PlayStation 4 Bluetooth wireless controller board firmware. It's this little bit here that gets corrupt when our controllers no longer sync. So that's the bit we're interested in. So what we're going to go and do now is we want to open that in HxD. So we're going to go across to HxD. Now if your file associations are actually set with HxD to open.bin files, you can just double click it. In fact, if you double click it and Windows asks you for a default program to open it with, and it's not in that list, if you browse or look for an app on this PC and go into program files, I think it's program files x86 if you're on a 64-bit, you'll notice this HxD application. There you go. And now when you double click bin files, you'll notice they'll open straight up. If you don't want to set your file association to HxD for .bin files because you've got some ISO burning programs or something like that, then of course just navigate excuse me, as we did there in Explorer. So into your folder where you've stored all your dumps and everything. So in our case, it's C:PS4 BIOS, originals extracted, flash underscore extracted, and this C0020001.bin file here. So highlight it, click open, and there we go. So this here is the entire PlayStation 4 Bluetooth wireless firmware as it sits on our flash ROM. So this is as our PlayStation 4 sees it. So how can we tell if that's corrupt, because it just looks like a load of old garbage to me? Well, have a scroll down. Have a scroll down, and you will notice that it all looks like complete gibberish and gobbledygook, and you know, how the hell are you supposed to understand what any of that means? You know, I'm not a computer, Andrew. It just looks like something out of the Matrix, you know? Keep scrolling. And hopefully, you're going to see a point where it stops looking like complete garbage and actually looks like something else entirely. So it all looks like complete crap at the moment, doesn't it? And you don't have a clue what any of that says, means, or anything else. Still looks like crap. Still looks like garbage. Oh, hang on, what's this? A big bank of Fs. So it had all that weird and wonderful garbled up stuff, and it all looked like the Matrix, and now we've just got a load of blank Fs in there. Lots and lots and lots of Fs. Lots of Fs. Lots and lots and lots of Fs. More Fs. If you were to scroll through that, it'd take you forever. So, loads of Fs. Look at how many Fs there are in there. Ooh. And then all of a sudden, you end up with more gobbledygook at the bottom. So, we get gobbledygook at the top. Right? We get gobbledygook at the top. And then that just randomly stops, and we get a load of empty Fs. And then the gobbledygook just randomly restarts again at the bottom. That's not right, surely. Well, if your firmware looks like that, ladies and gentlemen, then your controller sync issues are indeed caused by corruption in firmware. Congratulations, you found your problem. So, if you don't want to, I mean, to be honest, you know, that's the easiest way of finding it. You just have a quick scroll through. If you see a big block of Fs like that, then you've got corruption. An easier way to find it, if you don't want to go scrolling through it, or you've scrolled through it and you think you've missed it, or you can't see it, is to actually go into this search, find, or Control and F on your keyboard for a shortcut, and then just type a string of, say, 10, 12 Fs in there. So don't do it as a text string, do it as a hex value. So this data type field here, just drop it down and click where it says hex values, and then search for, just type in there, like I said, 10 or 12 Fs. So FF, 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 FF. So that's 12 Fs. Search direction is all, because it'll just look through the entire document, or this entire bin file, should I say, looking for where 12 Fs in a row turn up. So it's not impossible, as you can see in the middle of firmware. You do get the odd blank bit, but that being said, you can hit F3 on your keyboard or go search find again. And that'll find the next point where it finds the same string of Fs. So I'll just keep F3ing. And as you can see there, on the third occasion, we ate this big block of Fs. So if you find, you know, a tiny little string of Fs together like that in the middle of that code is perfectly fine. But this massive block of Fs, this massive old block here, where you get nothing but Fs, is corruption, because anybody who doesn't know anything about hex editing, F actually refers to blank space, so nothing at all. If you were to erase that chip in its entirety and then dump it again, all you would get is a 32 megabyte file full of Fs. So F is 0, nothing, nada, blank space, nothing there at all. So what you've actually got here is a big blank empty space in the middle of where your firmware should be. So if it looks like that, ladies and gentlemen, you have indeed got knackered firmware, and we need to fix it. Happy days. So this is where it changes slightly depending on whether you have a older PS4, so one of the 1000 series or a 1200 series. So how do you fix it then, Andrew? Because I'm desperate to get back to playing some whatever it is these days. So close that, and you need to go into where we extracted this zip file we downloaded right at the start, this C0020001 Templates folder. So go into there, and you will see that it's arranged in a collection. So at the top there, you've got a folder for SAA001 boards and SAB001 boards, and of course the later SAC001 boards. So if you have a CUH1000 or a CUH1100 series PS4, you are going to want that top folder there. If you have one of the so-called slimmer, quieter, CUH 1200, 1250 models, you are going to want to look in this SAC001 folder. And what you want to do, because we are going to be looking at it was an 1116A, wasn't it? So we are going to be looking in this folder. So because obviously for the newer PlayStations, the 1200s, we're just going to touch on that for now. So what you need to do, because the process is the same, but the way you identify which file you need is slightly different. So this is why we're going through this for you guys now. If you disassemble your PlayStation down to its motherboard and get the motherboard out, we have a 1200 disassembly tutorial on the channel already. We'll link it in here in an annotation. If you go watch that, you will be able to strip your 1200 series PlayStation down to its mainboard. Once you've got the mainboard out, take a look on the top of the little Wi-Fi Bluetooth chip, and you will notice it will have a model number printed on it, and it will say either AW-NB218, or if it's a later one, it'll say something like DHSM-PS97. So once you've found which type of chip you have on your board, go into the relevant folder. And again, if you look back on the sticker on your Wi-Fi Bluetooth chip, you will see it will have a revision number marked on there. So, in the case of the AW-NB218, you'll either have a revision 1.0, revision 1.1, revision 1.2. There may be others, but those are the three I'm aware of, or the ones I've come across. If you've got a DHSM PS97, congratulations, because as far as I know, well, certainly as far as I'm aware, there's only one, but there could be more. So if you have one of these AW-NB218s, take down the revision number and go into the relevant folder. Okay. If you've got one of these DHSM PS97s, as far as I'm aware, you've only got the one file for now. But either way, okay. So what you will find in these folders is a bin file, rather like the one we've just been looking into. So this C0020001 file, and effectively what that file is the exact same as the one we've just been looking at, but these are working versions of the Bluetooth Wi-Fi firmware for your PlayStation. So whereas yours is corrupt, these are actually working dumped versions that we're going to be able to use. So as I was saying earlier, we have a 1116A machine to look at. That's using an SAB001 motherboard. So we're going to go into that folder. Now then, as I say, if you're using a 1200 series and you've got an SAC revision motherboard, you're looking at the Wi-Fi Bluetooth module chip, and you're looking at the label to find what the part number is and what revision it is, and that's how you identify which version of the C0020001.bin file you need. If you've got an older one, which chances are you probably have got an older one, you'll be looking in here with me, this SAA001 and SAB001. So what we need to do to identify what we need is we actually need to go and look at our extracted file. So the one that we've just had open in HxD to find the corruption, remember, was kept in this originals extracted /extracted folder, and indeed we've just looked in this file and found a load of Fs. So if you right mouse click on that file and go into properties, you will notice here it says size 440 kilobytes, but the size we're actually interested in is this one in brackets where it says 451,312 bytes. Make a note of that number and then go back into your templates and have a look here on the right hand side, and it says the top one there is 450,940 bytes. There's one there for 451,312 bytes, and there's one there for 452,728 bytes. Remember that number? One of those look familiar to you? Does one of those look familiar to you? Does one of those look familiar to you? That middle one there? Absolutely. So we're going to open that folder. And essentially that number there matches with that number there. So that's the one we need. We need the 451,312 bytes edition of this C0020001 file. So whereas with an SAA001 or an SAB001, we are looking for the actual size of that C0020001.bin file as it's extracted from our original firmware dump. If you're using a newer SAC revision board on one of the newer model PlayStation 4s, then you're looking for the label on top of the Bluetooth Wi-Fi module. You're looking for the revision number in the case of the AW series chipset. On the DH chipset, there's just the one revision of that for now, as far as I know. I think the DH one is only found on the 1250s. But again, somebody may know different, may have seen different. Feel free to correct me. But either way, by now you should have identified which one of these template files is the one you want. And you will have also noticed that in that same folder with the working copy of the file, we have something in there. We have a text document, and it says hex offset OX144200 or whatever it says on your particular for your particular version of the firmware. Now then, if you open that, there's absolutely nothing in it. The key information is actually in the file name itself, hex offset OX144200. You're probably sat there now thinking, I haven't got a clue what that means. Well, we're going to show you. So feel free to close anything else out because, we don't need to complicate this anymore. So what we're going to do is we're going to open that C0020001.bin file from our templates, the working edition that we've just found. So that's what we're going to be opening in HxD. So either double click it if you set your file association, or go to file and open and go find it and open it up, and there we go. Make a note of that number there, the OX and whatever the number is. So that's 0x144200 in our case. Make a note of that because you're going to need it in a second. The next thing you're going to want to go and do is, again, file open, or go find it and explore and double click it, is, remember how earlier on we made a copy into the root of that PS4 BIOS folder of our org0.bin file? Yep, that's the one we're going to edit and manipulate, remember? Go ahead and open that up. Now then, that offset number you've just made a note of, that OX144200 in our case, well, you're going to type that in a sec. So what you're going to want to go and do is you want to go make sure that your original 0.bin file, the one that we're going to be editing, is the Open Active tab. Go to Search and go to, or Control G shortcut on your keyboard, offset. Type in there the numbers after the 0x. So in our case, it was 0x144200. So in our case, we're just going to type 144200. Ensure hex is set there in the middle box. Offset relative to wants to be begin, but those are default, so just say OK. And you will notice that actually right at the bottom, the last line in our window here, our cursor has moved to 144200. So we're just going to scroll down a little bit further. So rather than being at the bottom of our window, that's actually at the top. Don't know why it does that. That's quite annoying. But anyway, so we are now at the start of our firmware. If you actually go and have a look back in your old 20001.bin file that we had a look through to find all those Fs, some of this might actually start to look a little bit familiar to you. because this is the start of the section where our Bluetooth and Wi-Fi firmware is, but this time in that bigger 32 meg file as opposed to that little tiny sample that we've just been looking at. So what we need to do is we need to overwrite that dirty, corrupt, knackered bit in here with our nice, clean, working bit in our template bin file, which we have opened just next door. So how do you do that? Well, go to the tab where your template 20001.bin file is, and either hit Edit, Select All, or Control A as a shortcut on your keyboard, and you will notice the entire block is selected and highlighted, ready for copying. Okay, so go to Edit, Copy, or Control C as a keyboard shortcut, and make a note of this thing here at the bottom. You will see a little section here that says length, and it says 6E2F0. So make a note of that number there, that's 6E2F0, and then go back to your original 0.bin file. And this time, if you go to Edit, you want to go to Select Block, Control E. And then you want to select this little radio button next to length and type that number we've just made a note of in there. So 6E2F0. Make sure hex is set at the bottom and then click OK. What that's done is that has highlighted that entire block of firmware. So what that has done is in our main firmware file, we have just highlighted the entire section from top to the very bottom of our Bluetooth Wi-Fi firmware. So the entire lot, corruption, good bits, and everything is now selected. We have a good copy that we've just copied into memory on our PC. So now all we need to do is overwrite that's in there now with our good working copy. So what we do is we go to Edit, Paste Right, not Paste Insert, Paste Right, or Control B on your keyboard. You will notice now that you end up with a lot of red text in the middle of your firmware. That's good because the red text essentially highlights where things have changed. So as we can see there now, we have a big block of red text because we have just copied and pasted the entire working section from our template firmware file into our main firmware file. And not only that, but it's all copied and pasted and written into the exact place we need it. And if you scroll up here, you will notice that where there were big blocks of Fs, there is now just lots of nice code, and it looks like the Matrix again. So if you just hop back up and you go to Search Go To or Control G on your keyboard, you'll notice this offset still says 144200. So say OK, and that will jump us right back to the very top of firmware where we've just finished editing it, and you should see that that line there where it says 144200, at the start of that line is where the red text starts. Nothing above it is changed, that's all still black. We saw at the bottom there, once we paste righted into the file, that everything below that section where where we had highlighted is still black, so that's all still good. So essentially what we've done there is we've just put a big patch onto our original firmware dump, and everything there now is good. So if we save that, so you can either go Control and S for save, press that little floppy disk icon there, whatever you like, or if you'd rather create a new file, you can do File Save As, and then call it something like Orix0 Fixed .bin or whatever you like, and then save, whichever you'd prefer, So we've now got that file, and you can see now that the text has gone black because those changes have been committed to the file, they've been saved, and that's that. So our firmware is now patched up, it's fixed, it's all good, it's looking really nice, and there's no more corruption in there. Happy days. So what we need to do now is we can close out of HxD because we don't need it anymore. We can close out of our templates because we don't need those anymore, and we can go back into our SPIway shortcut, because now we're ready to write that file back to flash. So what we need to do this time is we're going to issue a command back to SPIaway. So we type SPIaway.py. Remember to tell it what COM port to use. So in our case, it's COM port 3. Add a space. This time, I recommend you go and you type something called erase chip. And then hit enter. What that will go away and do is, again, it shows us the SPI information from the flash. We're just going to let that do what it wants to do. You will, of course, undoubtedly notice that now at the bottom it says erasing chip. That's because what we're doing now is effectively writing a load of Fs across the entire 32 meg of that chip. So remember earlier when we said, you know, if you erased the chip and then dumped it again, you would just end up with a 32 megabyte file which would open in HxD and show you nothing but Fs. Essentially, that's what we're doing to our chip now. We are putting where there was previously code, and of course the corrupted bit, we're just writing Fs across the entire lot to make sure that we start with a nice blank clean slate. So that's going to take a couple of minutes. That's just going to take a couple of minutes. So we're going to jump here and we'll come back once that chip erase is successful, and then we're ready to write back to Flash. So come back with me in a sec, guys, and we'll see what happens. Okay, don't worry. It's not. It may not be the end of the world just yet. So, okay, occasionally what you'll find is every now and again, and it's not often, because most of the time these things do fail by blanking out entire sections of firmware, but sometimes it can just be the odd bit that flips. So what you need to do is, rather as you've seen here, where we actually go in and identify the patch you'd need to use. So in our case, it was this 451,312 byte file. What you want to do is open that up in HxD. So either go in and use file open or double click it if you've set your file associations. And then what you want to go and do is open your extracted version. So remember how earlier on we used our original. I went to original extracted, flash extracted, and then open your 0020001 file there. So you've got both open side by side. What you can then do is go up to the top menu and go to Analysis, File Compare, just as we did earlier when we checked that our dumps were valid. And this time you'll notice that we have our extracted, corrupted, or suspected corrupted 0020001.bin file and our patch 20001.bin file open in the target file underneath, and that will compare both. Now any differences at all will be highlighted in here. Now, as I say, because ours is corrupt and is showing a big bank of Fs, of course, the first thing it picks out is the start of the big bank of Fs. But on yours, that may not be the case, but any sort of highlighted differences in here, and of course you can skip through, you can search for more things in there, but any form of differences, next difference is F6, so you can just F6 your way through this to find all the various differences. As I say, we do have a big bank of Fs in ours, but if you don't, but even one bit is highlighted there as being different, then you may very well have corruption. Follow the procedure that we've just done to patch your firmware up and then attempt to reprogram it. If, however, as earlier on when we compared our various original dumps to make sure they were valid, and you get a little pop-up there that says that the files are identical, then your particular firmware isn't corrupt and is in fact good. So in that instance, that's when you need to start taking a look and maybe thinking about replacing your Bluetooth Wi-Fi firmware chip on your mainboard, or at least getting someone to do it for you. So if you don't have a big bank of Fs, don't panic, you may still have corruption, and that's a good way of checking it. In fact, if you do have a big bank of Fs in there for corruption, that's a nice easy way of finding it. You just go into the analysis, file compare, comparing your patch you need to use or would need to use against your source, and usually the first thing that corrupts up is right at the start of that bank of F. So that's another way of finding corruption if you do have it, particularly if you've got it and you don't have Fs. Right, okay then guys, once everything's done, you will see there at the bottom, you'll get this message saying done, hopefully with a nice little timestamp there, so it tells us that it took 1 minute and 35 seconds to erase our chip. Brilliant. So now we're ready to write back our new fixed firmware to our flash ROM. So to do that, what we do is we go spiway.py. Remember, space, we tell it which COM port we want, which again in our case is COM3, yours might be different. Space. This time we're going to tell it we want to write and verify. So that is done by VWrite, VWRITE, space, and then we're going to give it the file path and the file name of the file we want to write back to flash. So that's that ORIG0 that we've just changed. So remember we saved it, and then just to show you, we did file save as and saved it as, I think it was ORIG0 fix.bin. So either of those two will work just nicely. So C:\PS4 BIOS / and then the file name. So as I say, we saved it over the original ORIG0.bin in there, and we also created that ORIG0 fix.bin, like I say, to show you the save as feature as well. So either of those two files will work nicely. If you just saved yours, then ORIG0.bin will do lovely. Obviously, if you gave yours a completely different name, then you want to type that name you gave it just in there. And then once you've specified that, just check it and then hit enter. And what that will do is, you can see there now, we get a message saying writing, and it's writing 512 blocks. Notice the number of blocks on the chip is 512. So it's basically going to image that entire bin file we've just saved to flash. So that chip is going to be overwritten with the entirety of the firmware file that we have just made, which is cool, isn't it? So it's going to take it a little while. It's going to take it around 10 minutes, 10 to 12 minutes to write that file back on this particular PC. Yours may be slightly quicker, it may be slightly slower, I have no idea. But either way, that is going to take a while because it effectively is over a serial connection. So it's going to take 10 to 12 minutes. We will come back once that is done, because you don't want to sit here for 10-12 minutes just watching it do nothing, do you? It's bad enough listening to me prattling on now. So just to give you an idea though, you can actually issue a write command without the V. So we typed VWrite. You can just do write. What that will do is that will just write the file back to flash without actually checking anything. VWrite is very nice because what VWrite does is, as it writes a sector, it reads the sector back and confirms that what it reads is what it's just written. So it tells us that what's actually on the chip is what we've actually specified to be on there. So we know now for certain, once this process is complete, what's on that chip is what is in our fixed bin file that we've basically just spent the last while editing. So we can be sure that what's on there is good and is what we actually want to be on there. So that's cool. So right now we're heading up to the 5 meg mark. I will see you back here when it's finished. So come and join me then, ladies and gentlemen, and we'll finish up and we'll get everything tested, and hopefully we'll have a working PlayStation. Right, okay, ladies and gentlemen, and there we go. That's it. As you can see, once it's finished, you'll get this little message here saying done. We can see it's written 32,768 kilobytes of 32,768 kilobytes, and it completed this time in 11 minutes 37 seconds, and that's it. So once you've got that done, you can close SPIway. You can disconnect the USB from your machine, and that's that. So we're going to shut down the machine now. Going to reinstall the flash into the PlayStation, and then we'll plug it in, and we'll see if it works. Okay, so remember before when we tested our PlayStation, of course, our controller didn't work. So we've got the USB lead in there now. So hopefully if you try to fire yours up in the first instance, it'll just work. But of course if it doesn't, don't give up hope just yet, because what sometimes you need to do is actually initialize your PlayStation. Now, this one was initialized anyway, but we'll just go through it to show you what to do if you're not sure. So press and hold power, rather like we did when we came to test it. You'll hear a second beep, and then release, and that will boot your machine down into safe mode. So with the controller connected by USB, hit the PlayStation button, and then go down to where it says initialize PS4, hit the X, and then go across to where it says yes, you want to do that, and that will go away and initialise. Now, as I say, hopefully after this repair your machine will just start up and behave as though nothing was ever wrong with it. But every now and again, one or two people around the net have said that when they've done it, they've realised that, oh shit, it didn't work. And then they've had to initialise the machine, and then it's been absolutely fine. So that's just to confirm there what you need to do to initialise your PlayStation, if indeed, in your instance, it doesn't work. So we are going to test this now anyway, so it's going to come back up in a sec. I mean, this machine was actually initialised anyway, so it wasn't as if we were going to lose anything. If you were going to initialise it, obviously be aware that anything on your hard disk would go, but obviously if you had a PlayStation Plus subscription, then you know it should all be available on the cloud ready to download back without too much trouble. If not though, unfortunately, because you can't get Controller Sync to work, you're just going to have to bite the bullet. So anyway, here is our PlayStation. Remember, we still have the USB lead connected. Charging light is on. So remember how this was just blinking away before? Well, let's press that PlayStation button and see if we get sync. What do you know? Let's disconnect the USB. USB is disconnected. Controller is here. We have sync. Look at that. We're working again. So let's run through the setup wizard. Brussels. Well, it's gone down to Brussels. I have no idea. London. That's us. Set the date and time. I have no idea what the actual date and time is. 1828 apparently. A momentous day for Controller Sync. It'll be 1829 by now, won't it? By the time we've done messing around. Ooh. Oh dear. User 1. We are in. Hey, lovely stuff. And that, ladies and gentlemen, is that one. So we'll just power this machine down. Remember, I'm going to do it by the controller. Why not? Preparing to turn off. And that is us finished, ladies and gentlemen. So hopefully you've learned something out of that today. If you're in that boat, then as you can see, it's really not too difficult to get out of. It's just, you know, it's a bit of a faff. Hopefully though, you know, if you were just watching along just for something to do, hopefully you found it interesting and you've learnt something there. As always, please comment, even subscribe to the channel. It's always much appreciated. And if you have a look on the channel page, you'll notice a little Twitter link in the top right corner now. New videos and things will be announced on there. Updates to videos will be announced on there, and that's where they'll probably be announced first before they hit YouTube. So if you want to keep abreast of what we're doing or what we're thinking of doing, then hit me up there. If you've got any video suggestions and ideas, obviously comments and messages and tweets and things like that will be much appreciated. And hopefully we'll not keep you waiting too long till the next one. So any questions, boys and girls, or any problems, do pop them in the comments down below. And remember to thumbs up. And I will see you on the next one. So thanks very much from me, and it's ta-ta for now.